Okay, so continuing on to level 2 from our Krypton challenge here, you can see we have Route 13 is a simple substitution cipher. Substitution ciphers are a simple replacement algorithm. In this example of a substitution cipher, we'll explore a monoalphabetic cipher, so that's kind of what we did in the last challenge with the Route 13. This level contains an old form of cipher called a Caesar cipher. So a Caesar cipher shifts the alphabet by a set number. For example, A is going to map to G, B is going to map to H, C to I, and everything is just shifted down. In this example, A is mapped by G. For example, bad becomes BAD is HG, and then J, which is here. So for level 3, it's stored in a file called Krypton 3. So let's go see if we can check that out. We'll fire up a shell here and SSH into our Krypton 2 at krypton.labs.overthewire.org. We'll use our password that we got in the last episode from level 1. If you haven't seen that, go check that out. And let's go ahead and head into our Krypton 2. And we should see, yep, okay, so we have our Krypton 3 file. So this is what we need to eventually decode. So let's go ahead and take a look at that. So that's our password that we need to decode. We have a README in here, so let's go check that out. So this looks like it's the same thing from the website. So the password for level 3 is in the file Krypton 3, so we check that out. It's in a 5-letter group ciphertext. It's encrypted in a Caesar cipher. Without any further information, the ciphertext may be difficult to break. You do not have direct access to the key, however, you do have access to a program that will encrypt anything you wish to give it using the key. If you think logically, this is completely easy. So we saw this before. So this is the files here. So we have the encrypt binary, which is going to use this keyfile.dat to encrypt according to whatever this key file is, but we don't actually know what's in this keyfile.dat. We don't have permission to look into this. So what we have to do is use this encrypt function to figure out how we're shifting the cipher. So what we want to do is we want to kind of follow these instructions that are laid out in the README. So we're going to set up our environment to essentially be able to pump our plain text through that encrypt and be able to save it somewhere. So I'm just going to go ahead and follow these instructions here. So mktemp.d is going to create a temporary directory for us to use with some random characters. I'm just going to copy that and cd over into it. Then what we want to do is link the Krypton 2 file, the krypton.dat, or the keyfile.dat. So we can use this over in our file now. So if we do ls, we have this file in our temporary directory. We want to give this directory access to Krypton 3, and then we want to do a test run, essentially. So this /etc/issue, if I go ahead and look at this, is just it's a little ASCII message, and then we can use the /krypton2 encrypt function that we saw before, that red highlighted binary, to encode this. And what it's going to do is it's going to pump out a ciphertext file of the decoded message according to the keyfile.dat. So if I go ahead and look at this, so cat ciphertext, we get this encrypted message. So what we have here is an example of a chosen plaintext attack. And what that means is we can choose whatever plaintext that we can run through the key, and we'll see the ciphertext pairing. This is a pretty powerful attack if you're from an attacker. This is opposed to like a known plaintext attack where you're only given a certain amount of plaintext, or a known ciphertext attack where you're only given a certain, you're only given the ciphertext and you have to figure out the plaintext. So a chosen plaintext attack is pretty powerful. So let's go ahead and see if we can use this. Is there any more info in here? No, that should be it. Okay, so our initial thought process is that we can choose any plaintext that we want to run through this encrypt function and see how it encrypts. So my initial reaction is to just run the entire alphabet from A to Z through it and see how that shifts. And then we should be able to deduce how it's doing its shift and be able to use that on the file that we want to use. So let's go ahead and do let's make a temporary file in our temporary directory called, we'll call it ptext for plain text. And then what we want to do is we'll go ahead and head into this file, and I'll copy in our alphabet string from A to Z. And there we go. So now let's go ahead and save this. And so now if we cat ptext, we have our alphabet string from A to Z. And now if we run this through the encrypt function, So let's go ahead and do /Krypton/Krypton2 /encrypt, and then we'll give it the file ptext. It should pump out this ciphertext file, and if we cat ciphertext, okay, so here we go. So this is the string that it pumps out, and you can see it starts with M, goes down to Z, and then goes back up to A, and down to L. So this looks very similar to ROT13, except it's just rotating a different place. So with this information, we know that it's going from this standard set of characters over to this new mapping here. So anytime you encrypt the letter A, for example, you're going to get an M. Anytime you encrypt the letter I, for example, you're going to get a V. I think that lines up. So let's go ahead and do our text rotate. So we can do /cat /Krypton/Krypton2 /Krypton3. So that's our file. So if we look in this, this is the thing that we wanted to decode from the beginning. So let's pipe that over to our text rotate command. So what we want to be doing is we want to be decoding now. So this was the encoding function. So we're taking this and we're encoding it to this character set. So we just essentially want to go the other way. So we'll set up our character set here and we'll just copy this in. So this is the character set that we're decoding from, because this is the encrypted ciphertext. And now what we're decoding to is the string of A to Z, and I'm just going to write the shorthand A tag Z. And there we go. That's our password for the next level. Caesar is easy in all caps. This is a really good example of how a chosen plaintext attack could be utilized. All I did is give it the standard character set, see what it maps to, and then just rotate it back. The shorthand for this, just if you guys are curious, would be to write M down all the way to Z, so M tag Z, and then A all the way down to L, and that's going to give us the same thing, if you guys wanted to know the shorthand way to write this. So let's go ahead and log out of this SSH session, and we'll go ahead and do Krypton3, and then the password, I'll just copy over from here. And there we go. Now we're in Krypton 3, and that level is done. So I will see you guys in the next episode.